Okay, let's go over the sample test for the 154 final. It says convert 2 divided by pi from in radians 2 degrees. So to get the radians to cancel, we have to divide by pi and we have to multiply by 180. So times 180 divided by pi. Oop, times, what happened there? We'll insert 1, 8 times 180 divided by pi. And it's 36 degrees, 0.4756 carry out quite a few decimal places there. But now we have to turn that degrees, minutes, seconds. So we're going to say that's 36 degrees. Get rid of that. And then take this times 60 to get the seconds. And there's 28 point something minutes. So I'm going to take away the 28 minutes. And then I'm going to take this times 60 to find out how many seconds. 32.25 seconds. Okay, number 2. Convert this back to radians in decimal form. So we have 232 degrees plus 35/60ths of a degree, 35 minutes, and then 14 seconds is 14 divided by 36 hundredths. 60 times 60 is hundredths, 36 hundredths. And there's the answer in decimal form for degrees, 232.58722. Now to convert that to radians, I have to get the degrees to cancel and get radians, so I have to multiply by pi and divide by 180. And I get 4.05941 radians. Find the exact value of this. So we have the square root of 2, the cosine of negative 135. That's 45 or somewhere here, negative 140, 45, 90, 135, right there. And the sine and cosine are both negative square root of 2 over 2. Cosecant is the reciprocal of the sine. So that's going to be negative, of course, because in this quadrant, and the reciprocal of the sine is square root of 2 over 2, just like the cosine is there. So the cosecant would be, reciprocal of sine is 2 over the square root of 2. So this one becomes minus 2 over 2, which is minus 1, plus 8 over the square root of 2. And if I were to multiply, that's fine to leave it there. If I were to multiply by square root of 2 and square root of 2, this would become a 2, which go in the 8, make 4. So minus 1 plus 4 square roots of 2 would be nice. Secant theta is negative 5/3. So that means secant, the cosine is negative 3/5, because that's the reciprocal of the cosine. And the tangent is positive. So sine squared theta plus cosine squared theta equals 1. So negative 3/5 squared is 9/25. So if we subtract 9/25 from 25/25, we get the sine squared theta equals 16/25. Take the square root of both sides, and I get plus or minus 4/5. And if the tangent's positive, and it's cosine, sine over cosine, and the cosine's negative, the sine better be negative. So the sine has to be -4/5. And now the formula for tangent of 2 phi, you could do sine of 2 phi over cosine of 2 phi, but the formula says 2 tangent phi over 1 minus tangent squared phi. I should make that phi. So this is going to be 2 times the tangent. Let's see, that'd be sine over cosine. The negatives would cancel. 4/3. 2 times 4/3 over 1 minus 4/3 squared. So that's 8/3 over 16/9 from 1. That's 1 is 16, and 9/9 minus 16/9 is -7/9. So if I multiply the numerator and denominator by 9, that would make 24 over -7. Number 5 says graph this. Give the amplitude. See, the amplitude would be 2, not -2, 2. The period, that would be 2 pi divided by pi over 2. If I multiplied numerator and denominator by 2, I'd get 4 pi over pi, which is 4. So the period is 4. And the transformations, so this is flipped transformations, not just translations. Transformations. So the negative on front does a vertical flip over the x-axis. Let's see. The pi over 2, that's a little bit greater than 1, causes it a horizontal compression. By a factor of pi over 2. The vertical flip, I should say, was because of the -2, and there's also a vertical stretch. I should put that in there right with this one. Or an increase in the amplitude of 2. And then we have one final thing here. We got two final things here. We got minus 0.5 inside, so that's horizontally. It is shifted to the right 0.5. And this -1 is a vertical. Translation, or vertically down 1, or a new center line at -1. So if I make this be -1 and -2 and -3, 1, 2, 3, and I got a period of 4, so if I go out here 1, 2, 3, 4, and 1, 2, 3, -4. I have a cosine that would normally start off of the center line. Let's see, where is the center line? The center line is at -1. We have an amplitude of 2, so 2 either side of that. So that's from 1 to -3. And we start off of the center line, normally at the top, but since it's negative, it's at the bottom. And in 1/4 of the period, we're on the center line. Another 1/4 of the period, we're at the top. Another 1/4 of the period, we're back on the center line. And then at the bottom. And same on the back side here, on the other side of the y-axis. Center line, top, center line, bottom. However, this is shoved 0.5 to the right. So this point becomes this one. This one goes to here. This one goes to there, there, and there, 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 and there. So if I could make this curve, hit these crosses, that would be the graph. All right, page 2. Determine the equation. Okay, so center line looks like it is 2. Looks like the amplitude, looks like it goes off. Let's see if that's 2. This is 1, this is 0, so that's a half. So amplitude looks like it's 0.5. And it's starting upside down. And off of the center line, so it looks like it's a cosine curve. And it doesn't look like it's shifted at all. Let's get the period, though. Now, the period is going to be 2 pi divided by how long the period is here. Well, it goes from the top to the top. Looks like the top is a little over 3. So I'm guessing it is pi on this side and pi on this side. To repeat, it has to go 2 pi. So the omega then, since the period is 2 pi, the omega is 1. So it got 1x, not shifted sideways. So we got y equals 0.5, but negative because it's flipped over. Cosine x, and not shifted up to, vertically up to, but no horizontal shift and no period shift. That one was pretty straightforward. B. Now remember, on these we try to make a curve that touches these. So we're going to try to write the equation for this and then write it with the reciprocal. Well, this is 0, this is 5, so this is 1, looks like the low, and 5 is the high, so 3 must be the center line. Amplitude looks like it's 2, and if I just use this as a cosine, it's just off a little bit, so I'm going to say it's shifted. Let's see, if this is 5, this is 1, looks like about 0.5. Horizontal shift of 0.5 to the positive, to the right. Let's do that. Okay, and so I'm writing this with thinking a cosine curve here, so it will actually be, this curve will be the reciprocal cosine, which is secant. And the center line I'll take care of right away. 3. The amplitude is 2. It's not vertically flipped. And the period, what's the period here? Well, it's from the bottom. It's at the bottom going up, and then at the bottom going up. So it'd be from here to here. So that looks like it's about, that's a full period. So half the period would be from here to there. And that looks like, from a half to 4.5. So it looks like 4 from here to there. So it must be 8 from there to there. 1, 2, 3, 4, 5, 6, 7, 8. Yes, looks like it's about a period of 8. So omega would be 2 pi divided by 8, which is pi over 4. So I'm going to put pi over 4 times x in parentheses shifted 0.5. And it's to the plus 0.5, so I do minus 0.5. All right, number 7, you can remember how to add this all to the calculator, but I'm going to do it manually here. You can put list the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in list 1 and put these in list 2. But I'm just going to get a rough approximation here by going, okay. So the period is 12. So 2 pi divided by 12, because we're talking about daylight hours in Anchorage, so it's based on a 24-hour, or 12-month period, and these are the months, so omega is going to be 2 pi over 12, which is pi over 6. Let's see, the highest we have, the most daylight hours is 9:21 here. 1921. The least amount of daylight hours is at December, 5 hours and 28 minutes. So the difference there, dealing in time, so this is a little bit tricky. I can't say it's 19.21. So let's do it here. 19 hours plus 21/60 of an hour divided by 60. 19.35 hours. And 528 is 5 plus 28 divided by 60. 5.47. So subtract them, and I get 19.35 minus 5.47. So it looks like the double the amplitude from the max to min is 13.88. And the average of those two, 19.35 plus 5.47 divided by 2. The center line is at 12.41. That's the average of the high and the low. And the amplitude is half of the 13.88. A 6.94. Because if you go from the top to the bottom, that difference is 13.8. So the amplitude is from the center line to the top or to the bottom. So it's half of the 13.88. And the center line's halfway between that max and min. So that's why I took the average. So I'd have an equation. Y equals, see, we go with amplitude, 6.94 sine, and then we have pi over 6. And this is time or months or whatever, but I'll just leave it with an x. Minus or plus, we're going to have to shift this. Plus, the center line is 12.41. The shift we need to make is, we need to get this C. The low spot is at December. But if we're writing with the sign, December January is 1. So December is 0. And it has that as the low spot. But the sign starts at the center line. So we have to move the sign over however much. See, it's on the center line 3 months later, and then it's midsummer, another 3 months, so we have to move it 3 months over. So I'm putting it 3, and then to get it to match this form where there's no parentheses in here, I'd have to take the pi over 6 times this, so it'd be pi over 6x, and pi over 6 times 3 is 3 pi over 6, or pi over 2. Close enough, and if you do it on the calculator, you should get close to that same answer. Page 3. Okay, so cosine inverse, and it's capital, so we're taking it from cosine inverse. We take it out of the top 2 coordinates, and it's square root of 3 over 2. It's positive, so that's not really a concern. We're going to be in the first quadrant, and it's square root of 3 is the long side, so this would be pi over 6. And we're supposed to do this in radians. 30 degrees, but in radians. Cotangent is -1, so that means the tangent inverse is -1. However, the tangent inverse would give us an answer between minus pi over 2 and plus pi over 2, and cotangent inverse is supposed to do it in these 2 quadrants. So where's the tangent -1 in these 2 quadrants? Well, that's right there. That's on the quarter, so it's 1, 2, 3 pi over 4. Now it says the cosine of 11 pi over 8. Okay, so we've got to go by 8s. So 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. So I'm 1/8 off of here, 3/8 off of there. So the cosine there would be just this length. Now the cosine inverse, we have to find one in these 2 quadrants that has the same cosine. Well, it'd be 1/8 off of this, or 3/8 off of this. But we have to do it from here. So that'd be 1, 2, 3, 4, 5 pi over 8. The tangent inverse, so we'll make a triangle here. And think of this angle, and the tangent is 1 over u. So that's opposite over adjacent. That was the tangent. Now we've got to find the sine. And the sine would be the opposite over the hypotenuse. So we've got to figure out the hypotenuse. So this would be the square root of u squared plus 1 squared. So the sine would be opposite over the hypotenuse. Number 9. Appropriate sum or difference formula for this. Well, let's see. We have cosine, sine, sine, cosine. Okay, so when they're mixed like this, this is the sine of alpha minus beta, since it's minus and the sine is always the same sign. So I'm supposed to start with sine of alpha cosine of beta. So this must be the alpha, the first one, and this must be beta, the second one. So this must be the sine of pi over 6 minus 2 pi over 3. So if we get a common denominator, this would be 4, 6. So 1 6 minus 4 6 is sine of 3 pi over 6. 3 pi over 6 is the sine of pi over 2, which equals 1. Okay, so now we got to use the tangent of the difference formula. And the tangent formula is tangent of alpha minus beta, because we've got two angles subtracted, is tangent of alpha minus tangent beta over 1 plus tangent alpha tangent beta. The way I remember the signs is tangent is sine over cosine, and sine on the difference formula stays difference, and the cosine uses the opposite, which is in the denominator. So we use the opposite in the denominator and the same in the numerator. So now we have tangent pi over 3 minus tangent x over 1 plus tangent pi over 3 tangent x. And tangent of pi over 3, that's 60 degrees. The tangent is square root of 3 over 1. So that's the square root of 3. So we have square root of 3 minus tangent of x over 1 plus the square root of 3 tangent x. Prove this one. It looks a little funny here, but that's all right. Sine of alpha minus beta is, there's a formula. It says it's the sine of alpha cosine beta, same subtraction, cosine alpha sine beta. And that's times this. See, secant, and that's supposed to be secant alpha. Looks funny here. So secant alpha is 1 over cosine. So that would go in the denominator. And cosecant beta, so that's 1 over sine. So that would go in the denominator, sine beta. So I put this under this, I would get sine over cosine of alpha, which is tangent alpha. And cosine beta over sine beta, that would be cotangent beta. Minus, and then cosine over cosine would be 1, and sine over sine would be 1, so minus 1. Okay, cosine 2 alpha. So that's cosine squared alpha, theta, plus sine squared theta, plus another sine squared theta. That's one formula we have for this, over the cosine of theta. Well, cosine squared, no, this is minus. Cosine squared minus sine squared is the cosine of 2 theta. So sine squared minus sine squared would be gone, and we'd left be cosine squared theta, beta of theta over cosine theta. One of these would cancel, and I'd be left with cosine theta. The next page, if I can get it to happen here. Find all the exact solutions to sine of x equals square root of 3 over 2. Negative square root of 3 over 2. Where is that? The sign would have to be the longer one in the unit circle and a negative, so that would happen at minus pi over 3 or 5 pi over 3, and it also happens at 4 pi over 3 or minus 2 pi over 3. So all of the solutions would be, well, I could use this, which is minus pi over 3 plus multiples of 2 pi. So that's one set of answers. Or x could be, the other place is this place over here, 4 pi over 3 plus multiples of 2 pi, where m is an integer, or is an element of the integers, if you want to write it that way. Whoop, that was a funny thing. Okay. Find all the solutions on the interval from 0 to 360. So now we get to do it in degrees. And so if I subtract or add 3 to both sides, I get the tangent squared x equals 3. Take the square root of both sides, I get the tangent of x equals plus or minus the square root of 3. And that's special angles. The tangent is square root of 3 when the sine is the long and the cosine short. So that's at 60 degrees. It would happen here, but be minus, but that's at 120. And it would happen down here, which is 30 back from 270 is 240. And would happen down here, which is minus 60, but we got to go this way to be between 0 and 360, and that'd be 300. Determine x and y. Well, I have side angle side, and so that's what the law of cosines is set up for. So law of cosines would say x squared equals 5 squared plus 3 squared minus 2 times 5 times 3 times the cosine of 67. So working that out, 25 plus 9 minus 30 cosine 67. And I better make sure I'm doing degrees. Nope. Did I change that? Nope, I didn't. Enter. Second quit. Enter. Now I got an answer that makes some sense. Oh, and that is what x squared is. So I got to take the square root of both my answer. And I get x to be 4.72. Now I have 3 sides. I can always find another angle, or I can use the law of sines. Let's use the law of sines, since some of you might not have the program. So I'm trying to find an angle. So the sine of y over the side opposite is equal to the sine of any other angle, 67, over the side opposite, which is 4.72. So I'd multiply by 5 on both sides. And so I'd have sine 67 times 5 divided by 4.72. That's what the sine of y is. So then I take the sine inverse of that answer, and I get y to be 77.19 degrees. Here we have side, side, side. We need to find an angle. So that's the formula where the angle is equal to cosine inverse of the two adjacent sides squared minus the opposite side squared divided by 2 times adjacent times adjacent. And is this a triangle? This would be 29 and 27. So this is really big angle. These are really close to that. So we should get a really small answer for this angle and big angle there. So let's see what we get. Let's just work out the inside. 14 squared plus 27 squared minus 15 squared divided by parenthesis 2 times 14 times 27. And then we got to take the cosine inverse of that answer. And I get x is 22.19 degrees. Find the length of segment AB and the area of the entire figure. Length of AB. So we have angle, 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 sides. Angle, angle, side. We should be able to use the law of sines to figure out AB. Let's see. To figure out AB, we'd have to do sine. Let's see, I want to get AB, call that x. So x over sine of 105 equals 9 over the sine of 15 degrees. So I multiply by 105 sine of 105 degrees. So I have 9 sine 105 close parenthesis divided by sine 115. There we go. So x is 33.59 approximately. And then to figure out the area, we're going to have to figure out the area of this triangle and this triangle. I have this side, and I need two sides and an angle between them. Well, I have that side. It would be advantageous to have this side. So I'm going to use the law of sines in this angle to get this side. So to get this angle, I'm going to add 15 to 105, which is 120. And that leaves 60 for this one out of 180. So I'm going to write, I'll call this y, then y over sine of 60 is, doesn't matter which one, I'll use the one we had here, 9 over the sine of 15. So instead, I'll be doing the same as we did before, except now instead of 105, we're doing 60 degrees. So I'm going to go back here and change this to 60. And I'd get y to be 30.11. So the area of this top triangle, I could use side angle side or side angle side or side angle. I can do any of those and get that. The formula is 1/2 side times the sine of the angle between. So for the top triangle, let's say I chose the 60, I'd have the 33.59. Oop, got an extra 3 in there. 33.59 times 9 times sine of 60, all half of that divided by 2, and I get 131 units up here, square units, and down here I'll do the same way. So I got a side 10 times another side 30.11 times the sine of the angle in between those two, which is 28. And we only want half of that. So this one is 70.71. So a total area is, my total area is 202. Square units. 17. A radar station spots a plane east of the position at a distance of 7 miles. So if this is the position and east of it, so that's this direction, 7 miles is where a plane is. And a second plane at a distance of 5 miles 22 degrees south of east. So that's east, so 22 degrees south. So if the radar station's here, 22 degrees south of that at 5 miles. How far apart are these planes? So we could actually use the law of cosines to figure that out, or we can do it in vectors. So to find this, we could do law of cosines. This is the opposite side, so the distance between them is the square root of 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of the angle between them. And so the distance between them is, let's see, 49 plus 25 minus 14 times 5 cosine 22. And then we got to take the square root of this. And that is 3.016 miles. Now, if you wanted to do it with vectors, you would want to take this one and find out its x and y, and then find out its x and y on this one, and then subtract them to find out the difference between them, how far it is in the x and how far it is in the y, and then get the hypotenuse on that one, and that would do it also. Convert rectangular coordinates to polar and vice versa. So if those are rectangular, x and y, to get polar, the radius is the square root of that squared plus that squared, so 49 plus 25. And take the square root of that answer, and it's the radius is 8.6, and the angle is tangent inverse of y over x. So it's going to be tangent inverse of 5 divided by 7. And do I need to add 180? The x is positive, so nope. And so the angle is 35.35 degrees. 5.3 degrees. 5.4 rounded off. Okay. This is x and y, so this would be r sine theta. That's what y is, plus 2. And then x is squared, so it's going to be r cosine theta for one of the x's times another r and another cosine. So that's x squared equals 4. Good enough. Now, if this is r and theta, to find x, you take r cosine theta. So we go minus 2 cosine of negative 220. And the x is 1.53. And let's find the y. It's the same stuff except with a sign in it. And that's negative 1.29. Now let's see if this makes sense. The y is negative and the x is positive. Negative 220, negative 180, negative 220 is somewhere up here. And we're going a negative radius, which takes us this direction. So the x would be positive and the y would be negative. It does make sense. Okay, on D, we have 3r equals secant is 1 over the cosine of theta. Well, let's just multiply both sides by cosine, and we get 3r cosine theta equals 1. Well, r cosine theta is x, so we have 3x equals 1, or x equals 1/3. Okay, now we have a ship is sailing 4 knots at a heading 22 east of north. 22 degrees north is the reference, east of it by 22 degrees. So headed this way at 4 knots. Current is causing it to drift from that heading. The current is 2 knots towards the southwest. So the current's in this direction, and it's 2. So that's going to pull the boat off of this heading this way. So if I do this with vectors, I have the first vector, 4 knots at, and if it's 22 off of 90, then it would be 68 degrees in trig. And the other one I have is 2 at, and if it's southwest, that's in the middle, that's a 45, so that's 225. So if I figure out the x for cosine 68, 1.498, the y, which is just the same thing with a sign in there, and that is 3.709. Then for the other one, 2 cosine 225, and that should be a negative 1.414. And since it's at 225, the signs in that quadrant is the same, so it's negative 1.414. Add those two together. And since these are opposite in sign, we're going to get 0.084. Excuse me. And we're going to get the y. See, that's negative, that's positive. We're going to have to subtract. That's 5, 9, 2, 2. Both of these positives are bigger than negative, so this is positive. So it's slightly to the positive x and mostly positive in the y. So x is positive, so it's going to be a little bit to the east of north that we're going to be traveling. Let's see what this works out to be. So convert these back, so I got to square them. 0.084 squared plus 2.295 squared, square root, and the boat will actually travel at 2.296, 2.30 knots roughly. And its heading will be some east of, a little bit east of north. To get that, we do the tangent inverse of 0.084, y over x, so I got to do 2.295 divided by 0.084 and 87.9, which is 87.9 trig is, we got to take that from 90 to find out how much it is east of north. So take 90 minus that answer, and it's at 2.1 degrees east of north. Okay, last page. So this looks like a limacon with an inner loop. So the farthest out this gets is 1, 2, 3, 4, 5. And it gets in, looks like -1. Looks like it goes from 5. And when we get over this side, it goes to -1. So it ranges from 5 to -1. So the average is 2. So this is based on a circle of radius 2. And you can see that here and here, radius 2. And we got a curve that's starting out or starting up. So that's like cosine. And it's got an amplitude of 3. Cosine. And it goes from out to on to in to on to out. So it does it once in one circle. Radius 2 plus 3. I think that would be the equation. And determine the vector in polar form. So that would be 5 squared plus -12 squared, but it doesn't matter if it's negative or positive. So that's 25 plus 144, which makes 169. So the length is a square root of 169, which is 13. So it's 13, comma, and then the angle. So it's going to do the tangent inverse of -12 divided by 5 And the x is positive, so we don't have to add 180. And it at negative 67.38 degrees. Determine the unit vector. Well, this vector had a length of 13. Its norm was 13, so we have to divide both sides by 13, or both parts by 13, so it's 5/13 I minus 12/13 J. And now the final problem. So it says U's pointing this way and V's pointing this way. What is U plus V? So we'd have to draw a vector that's going in the same direction, parallel, and same length. That looks about the same length. And it goes this way, plus V. So from where I ended, I'm going to start V, and I have to go parallel to V. So I have to say, is that parallel? Looks like it's the same direction and the same length. Let's do it this way. That length is about that long, which is about there. There's a V. U plus V would then be there, from where I started to where I ended. I went there to there to there. So I started here, ended here, and so there's the sum. Okay, now we got to go 4 V's. Ooh, that's going to take us a long way. And then a minus a U, that's going to take us up. So I'm going to start here and go a V. So I'm going to turn the paper here so it's easier for me to draw parallel to that one. I think that looks parallel and about the same length. That would be about that long, and then do another one. Same direction. Another one. So that's 1, 2, 3, 4, and I have to start over here far enough because I can't make any of these shorter to fit my paper. They have to be the same length. And I'm thinking this one looks a little shy. This one would take it about to there. And now I got to go a minus U. And U went down this way, so minus U goes up. And it's got to be parallel to this. Looking like it's the same angle over here. So up, and that's about how long U is. So that's a minus U, and this is a V, 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 V. So we got 4 V's minus U, and this vector here, it goes from where we started to where we ended. Okay, and that's the video of my sample test.